My name is Amy and thank you very much for watching. So we are going through the hard hat implementation for lesson 6, trying to get to lesson 7. We are about to do programmatic verification. During this break, I got myself some hot chocolate because I haven't drunk much today. And I unpacked my new laptop stand. Not my laptop stand. Cell phone stand. Which I couldn't take a picture of because, you know, my cell phone's on it. But, and now I can't pick it up because, oh man, my desk is a mess. There's a cable that I have, oh my gosh, okay. Anyway. It looks like this. I have my case over it here. So there's a thing for the cord in the back. It's just that, like, I have a keyboard. I have so many excuses no matter what I'm doing. But it's adjustable and everything. And since my wrist started hurting, I'm trying to stop, like, you know, using it to rest my chin and stuff because that is, I've learned a habit of mine. And then I bought this thing because I have that habit of when I'm in Twitter Spaces holding the phone. I'm left-handed, so I hold it like this, and I don't think that's a natural angle for my wrist, so I'm hoping that just by changing my habits, my wrist will stop hurting so much. So, also during the break, I checked to see what the notifications were, and it didn't take me into a new tab. And when I came back, it went back an entire hour, which is always fun. So, yay! Let's do some programmatic verification before I talk literally everybody's ears off without actually learning anything. But I want to get to lesson 7. I want to get through the Fund Me because I think, like, up to lesson 10 here, like, getting through lesson 10 is, like, the best part of this. And then, yeah, in lesson 15 I'm looking at as well. But I think by the time we get there, I am in a good position to start starting my own stuff. So.
All right, great. So we've deployed to Rinkeby using Hardhat. This is fantastic. Now, something that we notice, once again, is, a contract.
Also, I woke up this morning and watched 2 YouTube videos about making lazy NFTs, lazy mint NFTs, which are also called, like, signature NFTs. So I think we're going to try to deploy something like that on my website, and I will start inviting you along to program with me for, like, real programming adventures, because the Art Advocates Incorporated is going to be an open source dealio, and there's something sticking on my laptop monitor screen. Anyway, we're gonna...
Isn't verified. Do we have to go back through and do this verify and publish and all that stuff again? Well, lucky for us, we actually don't need to do that. So what can we do? Well, back in our deploy script, we can add some code to automatically verify right after we deploy. So let's go ahead and do that. Right below our main function, we're going to create a new function called verify. We're going to say async function.
Okay. They're literally going to call it function. I don't know if it takes any parameters or anything, but this is easy enough to do.
Function verify. And we're going to have this function get past some arguments. We're going to have it get past a contract address.
Which you could just say address, but it's fine. I'm used to having to do like the colons to tell people what it is with the TypeScript.
And some arguments for the.
Okay, so sometimes we do like args like that. And that just captures the rest of the arguments that are sent to the JavaScript function.
For the contract. Since our simple storage doesn't have a constructor, the arguments for simple storage are just going to be blank. But in the future, when we have contracts that do have constructors, the arguments are going to be populated. And when we get there, you'll see what I mean. We need at least the contract address. And we're going to add some code in here to automatically verify our contracts after they've been deployed. This auto verification process works on block explorers like Etherscan. It might not work on block explorers like Ethplorer or other block explorers, but if you want to verify on these other block explorers, I'm sure they have an API to allow you to do that as well. Now, Etherscan and most other block explorers have a section on their website called API documentation or something to do with APIs. These are ways for us to programmatically interact with Etherscan and do stuff with them. One of the main things that we can do is we can actually verify our contracts through this API. Etherscan even has a tutorial in here called Verifying Contracts Programmatically, and a link to this will be in the GitHub repo. They have an API endpoint that we can make some requests to go ahead and verify our contracts. Now, we could absolutely make the raw API calls and follow the tutorial here, but there's actually an easier way than even going through this tutorial here. Hardhat is an extensible framework, meaning you can add something called plugins to it. There's even an advanced section in the documentation called Building Plugins. If we scroll down to the bottom, we can see some popular plugins that the Nomic Labs team or the Hardhat team has created, and also a number of community plugins as well. One of the most used Hardhat plugins is going to be this Hardhat Etherscan plugin that makes this verification process much, much easier.
Okay, so if we go to hardhat.org, we go to, well, I guess we could just go to plugins and then probably this one. What is this installation? This one. And it says to do this, and then it says to add this require to the Hardhat config we conveniently have open here. I think it goes there. Do I need to define it anywhere else? Networks. So we have a networks here, whatever. Then, okay, so we're just going to add a new section called and we're going to do API key and just do a const. I don't know if I can expire it or not, so we're going to not show this as I'm doing it. I'm going to put it in my env file and then we'll never talk about it again. Okay, so Etherscan. Okay, So I'm gonna create an account. Okay. I'm not sure how much of this is dangerous, but hey. Okay, let me undo my display real quick. Let me Gmail and get to my verification. I am going to confirm. I'm clicking on the login. I'm not a robot. Crosswalks. I'm just going to continue doing this until traffic lights. Until I have my API key. And yeah. So I have done I am not a robot, so I'm going to log in. Let's look around here. So, API keys is down here. First API key. Copy. And we can delete. Okay, so I will remember to delete this later. Not great to do this like this, but hey. Okay. Then, what are we doing?
To install it, you can just run npm install -s save dev at Nomic Labs hardhat etherscan, and then add it to our hardhat.config. Since we're using yarn, we're just going to go ahead and use yarn. So back in our code, we'll do yarn add --dev at Nomic Labs /hardhat /etherscan. Now that we have this plugin, we can go to our hardhat.config, scroll to the top, and add this plugin in. We'll do require at Nomic Labs /hardhat etherscan. Now that we have this plugin, the hardhat documentation has some more information about the usage, how to actually use this plugin, and how to run different commands with it. In order for us to use this verification, we actually need an API key from Etherscan. This is basically a password for allowing us to use the Etherscan API. So we're going to come to Etherscan, and we're going to go ahead and sign in. And actually, we're going to click the sign up and create an account. And we'll go ahead and create an account. We'll go ahead and verify our registration by clicking the verification link. We'll click the login. Now that we're logged in, on the left-hand side, we can scroll down to API keys, and we can go ahead and create a new API key. We can call this HH-FCC, which stands for Hardhat Free Code Camp. Create this new API key. We'll copy this, and we'll go back to our code, and we'll add this somewhere. Since this API key is basically considered a password, where do you think we should add this? That's right, in our .env. So in our .env, we're going to add a new entry called etherscan API key, and we're going to add that API.
Oh, I'm really good at this.
Key that we just got. Now that we have our API key, back in our Hardhat config, we're going to create a new section in our module.exports to tell Hardhat that we have this Etherscan API key. Our new section is going to be called Etherscan. And in here, we're going to say API key is going to be Etherscan.
Okay, so did I do that part? Yes.
API key that we're going to define up here the same way we defined these other keys. So we'll say const Etherscan API key equals process.env.etherscan API key. And if something like this pops up, you can generally just hit enter and it'll autocomplete it for you, which is awesome. Great, so now we have an Etherscan API key. Back in the Hardhat documentation, it tells us by adding this, we actually get a new task called verify. Let's try that out. Let's open our terminal back up and we'll do yarn.
Okay, so npx hardhat verify.
Hardhat. And let's see what pops up. Wow, we did get a new verification here. When we run yarn hardhat, hardhat actually looks into our hardhat.config.js and checks for any plugins. If there are new plugins there, it'll add them as a new task that we can do. You can manually verify your contract by doing yarn or npx, hardhat verify, -- network, the deployed contract address, and any constructor arguments yourself. But we want to be a little bit more programmatic than this. So what we're going to do is we're going to go back and create this verification function. It is good to know how to do it via command line so that if you want to verify something in the future manually, you can. Let's build this verify function though. So we're going to take our contract address and some arguments. And for our sake, we're going to do console.log.
And then
verifying contract, ... just so that we know we might have to wait for a little bit. And in our...
Okay, well, I like that better. Okay.
code, we can actually run any task from Hardhat using a run package. So up at the top, we're actually going to import run from Hardhat as well. Run allows us to run any Hardhat task. So in our code here,
okay, ethers run run. The double run by SNDS. That's what's in my head right now. Okay, we're good.
we're going to do await, run, and then we can do verify. Now, Hardhat allows you to add different parameters as well in this run, and it's usually best that you go ahead and add them in here so that we're really specific with what we're doing.
Okay, so await, run, verify.
If we do yarn hardhat verify -- help, we can see what parameters we can actually pass. Well, it looks like we can pass the verify parameter, so we'll do :verify. If you go to the actual GitHub, for the verification task, you can actually see you can do more than just verify. You can do verify get minimum build, verify get constructor arguments, verify, which is what we're going to be working with, and a couple of other subtasks as well. The second parameter that goes inside run is going to be a list of actual parameters. This second parameter here is just kind of the subtask, if you will, of our verify task. And this is going to be an object that contains the actual parameters. And this is where we pass in an add.
Okay. You might be able to just do args if that's a thing.
Address, which is going to be our contract address, and then our constructor arguments, which is going to be args. Now, normally,
We've decided that doing the constructor, it's fine. Amy's fine. No notes. Okay, so constructor arguments, args. Let's stop using the mouse for things because, YouTube likes to start at the very beginning of things when you've been doing it for 9 hours. So, there's that.
Just this right here should be enough for us to go ahead and use this verify contract in our main function. But we're going to add one additional thing to it because in practice, sometimes there's some errors that can come up. One of the errors that often comes up when running a wait is that the contract has already been verified. And you'll actually likely run into this because Etherscan will get smart enough by seeing enough bytecode that is exactly simple storage that it'll start to just automatically verify any bytecode that looks like simple storage. And then this await will throw an error, which we want to avoid. So what we can do is we can add a try catch onto this await. So outside of the await, we're going to add a try.
Okay. Try with curly braces. You know how often they tell us to do try and catch and how often we just ignore them and just assume everything's going to go perfectly? No, I'm normal. That never happens. Of course I always do try and catch whenever I can. I'm just not weirded out, but like I was assuming that we would do like run and then catch as a chained thing.
We're going to add these little brackets that wrap around our await, and then we're going to put a catch E. This is known as a try catch. And Solidity also has try catches. But basically, this E is going to be any error that this section throws. So what we're going to do is we're going to say if this message is already verified, then we're just going to continue.
I do console error.
So we're going to say if E.message dot to lowercase, we're going to make sure it's to lowercase. That includes already verified. Then we're just going to do console.log, already verified, like that.
Okay, well there's another way we could do this. Unless, so... Okay.
Otherwise, we're just going to console.log e. The reason we do this is because if this errors, our verification function will break and our whole script will end. And we don't want our whole script to end. We want our script to keep continuing if the verification doesn't work, because it's not really a big deal. So I know this might seem like a lot of code. Feel free to copy and paste it from the GitHub repo to just move along. But awesome. So we now have a verify function using the verify task in Hardhat. Let's go ahead and use this now in our main function. Right below our deploy, we'll do console.log, deployed contract to, and then the contract address. But before we call this main function, let's think for a quick second. What happens when we deploy to our Hardhat network? Well, remember, if we deploy to our Hardhat network, will our contract need to be verified on Etherscan? Well, we know there's a Ring Etherscan, we know there's a Coven Etherscan, we know there's a mainnet Etherscan, but is there a Hardhat Etherscan? No, of course not, right? The Hardhat runtime environment is a network local to our machine, so it doesn't make sense for us to verify a Hardhat network deployed contract on Etherscan. So we actually don't want to call this verify function when we're working with our local network. This is where these chain IDs are going to come in quite useful. What we can do is we can check to see if the network that we're running on is a live network, or it's a test net, or it's a network that actually can be verified. We can actually get network configuration information by importing network like this, and we can do something like.
So up here we do the network, and down here printing only if not local. So probably like network dot
like console.log network.config. Now,
okay, so hard fork glacier chain ID is elite, but with a 3 in front of it. So if three 1337 or and okay. If we do this again, what we do network is Gorelli. We should verify the contract. Okay.
If I run yarn hardhat run scripts deploy.js on our hardhat network, since I'm not passing a network flag, we get this massive output that looks like this. Our network.config contains a ton of information about the current network that we're on. You'll see here that the chain ID of the hardhat network is actually 31337. We have gas price, which gets set to auto, block gas limit, the current fork of Ethereum that we're working with, and all these other pieces here. This chain ID is really important because we can use this chain ID to figure out which one is a testnet or which one is a live network. And remember, running this script is going to be the same as doing -- network hard hat. You'll see our chain ID is still 31337. Again, that's because the default network in our hard hat config is hard hat, which is the same as saying every single time we run a script, we're secretly running it with -- network hard hat. So now we only want to verify on our testnet. So what we can do is we can say if network.config chain ID equals 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 4, which is going to be ring B, and in JavaScript, equals 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 is nearly the same as equals equals, except no type conversion is done, which just means in JavaScript, 4 equals 4, and 4 equals equals the string of 4, but if you were to use 4 equals 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 4, this is false. So this is true. Equals equals 4 equals equals would be true. 4 equals equals to the string of 4 would also be true, but 4 equals 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 to the string of 4 is going to be false. So you can kind of do whatever you want here, equals equals or equals equals equals. So we want to say if the network.config.chain ID is 4, so if we're on ring B, then we can go ahead and actually verify. But we also want to make sure we only verify if our Etherscan API key exists. So we can also in here is say and this double ampersand.
So where's my deploy scripts? This one, and then basically and
means and we can say process.env.etherscan API key. This is some Boolean tricks that we're doing here basically. So our first conditional, we're saying if network.config.chain ID equals 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 4. This section can be true or false, obviously, right? The chain ID that we're running on can be the hard hat network, which would mean this doesn't equal 4, or it would be ring B, which means this does equal 4. But there's no conditional on this side, so how does this side work? In JavaScript, if an object exists and you try to cast it as a Boolean, it'll be converted to true. If it doesn't exist, it'll be converted to false. So in JavaScript, basically, if Etherscan API key exists, if we have this in our .env, this will be true. And if not, this will be false. So another way to read this line here is saying if network.config.chain ID is 4, aka if we're on ring B, and our Etherscan API key exists, then do some stuff. And that's what we're going to do here. So in here, we'd want to run verify, our verify function, and pass it the contract address, which is going to be.
So, yep. Verify contract. Do we have, oh, we are console logging the simple storage address. I don't think we have any args.
B, simple storage dot address, and the constructor arguments, which we know are going to be blank. And since our verify.
Okay, and since it's blank, just empty array.
Function is an async function and it deals with promises and stuff, we want to add the await keyword here. Awesome. So we've added a way to actually verify our contract, but we're not quite done. See, on Etherscan and all these block explorers, the instant we deploy the contract and the instant we send the contract, Etherscan might not know about the transaction yet. It might take a hot second for Etherscan to be up to speed with where the blockchain is. So it's usually best practice to wait for a few blocks to be mined until you actually run your verification process. We've actually learned how to do this already with the deploy transaction. So before we actually verify, we want to run await, simple storage,
Wait. Deployed.
Deploy transaction, await 6.
So wait for 6 blocks to.
So we will wait 6 blocks and then we'll run our verification process. Now, if you want to go and test this out right now, you absolutely can. I'm going to keep going though, because again, testing all these on a testnet takes a little bit of extra time. So I'm going to finish the rest of our main function, and then I'm going to run everything all together.
Okay.
Yep.
That means I get to take a small break. My new job asked me to fill out some paperwork. I need to go look at it and see what they're talking about. So we are at 9 hours and 6 minutes, which means we only have 54 minutes until we're done with this lesson. But yeah, thank you for sticking with me, and we will get through. Yeah, I'm like looking at all the time and all of this stuff, and oh my gosh, all the excuses. But yeah, give me a couple minutes. I'm gonna go look at my new job, what they want me to do. I'll make a list of what all I need to do, and then we will be back. And oh my gosh, I just want to get through this. So much, so hard. But yeah, this has been pretty smooth so far. I should probably not say anything because we are programming, which means that we can fall into a pit of despair really quick. So anyway, I will see you later. Bye.